Hello students, welcome to semester classes. In the question number 20, it is given in a cubic unit cell. 7 of the 8 corners are occupied by A atoms and the centers of the faces are occupied by B atoms. We have to find out the general formula. For solving this type of a question, let us first consider a cube. Okay, and A atoms out here are marked with the black circles, and according to some, one of them is missing, so we are not writing the or putting the circle in one of the corners. Contribution from the corners is 1 by 8. Okay, and these are your A atoms. Now for top, bottom, these are your B atoms. Left hand side, right hand side, back, and this is the front face. Okay, now these have a contribution of half. Okay, these have a contribution of half. So how many A atoms are there? So we will say contribution for A atoms. Okay. What is the number of atoms? We will say 7. How much they are contributing? 1 by 8. So total contribution becomes 7 by 8. If we say contribution for B atoms, since they are present in the face, so each of them are contributing half. How many of them are there? 6. So it becomes 3. So for formula, we will say it is A 7 by 8, B 3. If we multiply throughout by 8, then the formula stands out to be A 7, B 24, and that should be our answer. So if we check the options, what we will say, B is our answer. Okay, next question is a diatomic molecule has a dipole moment of 1.2 dB if its bond distance is 1 angstrom. What fraction of the electronic charge exists on each atom? Now, electronic charge for electrons, okay, for A electron is 1.602 into 10 to the power minus 19 coulombs. Okay, C stands for coulombs. Alright, this is for the answer of 21. Now the dipole moment which is mu is actually a product of charge into distance between atoms. Okay, now that is basically Q into D. Alright, so we know 1 dB or 1D is equal to 3.335 10 to the power minus 30 coulometer, and 1 angstrom is nothing but 10 to the power minus 10 meter. Okay, that is 1 angstrom. Now we got to find out Q, so therefore we will say Q is nothing but mu by D, and if you do the math, which is basically 1.2 D into 3.335 10 to the power minus 30 kilometer divided by 10 to the power minus 10 meter. So meter gets cancelled. Out here we will get this to be as 4.002 into 10 to the power 20 coulombs. Okay. Now the question is demanding what fraction of the electronic charge exists on each atom. So for the fraction of electronic charge on each atom, basically it is a percentage. Finding out the percentage, we will say Q by E. Alright, so that will come out to be 4.002 into 10 to the power minus 20 coulomb divided by 1.602 into 10 to the power minus 19 coulomb. Alright, and if we do this, we get it out to be 0.2498, or we can round it off to and say it is going to be 25%, and hence our answer over here is going to be C. Okay. Now in the question, white phosphorus when reacted with NaOH gives pH 3 and NaH2PO2, which is the salt of hypophosphorus acid. So for this question we will say we have P4 plus 3NaOH plus 3H2O, that is going to give pH3, that is phosphine, NaH2PO2. So if we use the oxidation number method and we try to find out the oxidation number on each of the elements, we will say this is 0, and out here this is minus 3 because hydrogen is plus 3, and for phosphorus obviously it will come out to be as plus 1. So here a portion of the phosphorus are getting, we can say, reduced, and we can also say a portion of the phosphorus are getting oxidized. So when the same element gets reduced and oxidized within a redox reaction, it is called disproportionation reaction. Okay, so obviously out here we will say our answer is going to be C. Now in question number 23, this is from periodicity. The first ionization enthalpy of the group 13 elements follow the order. Here, if you just remember Baggett, okay, so what is Baggett? BAG, that is gallium, indium, and then we have thallium. Okay, what do you have to remember? Bag it, that is BAG, bag it. Okay, now this will not be following the trend in which we have studied that if we go down, IE decreases. Okay, this will not be followed. Okay, there is anomaly over here. What is the anomaly? Thallium is a post transition element. Okay, and it shows inert pair effect. Why it shows inert pair effect? Due to poor shielding by d and f orbitals of the nuclear charge. Okay, so it has a high, so its valence electrons will be filling a high amount of effective nuclear charge, and so its IE will increase, so much so that it only comes after boron. Okay, it comes after boron. Among aluminium and gallium, okay, gallium has higher IE than aluminium because of, again, poor shielding by inner 3D orbitals. Okay, so it is followed by gallium, then followed by aluminium, and then followed by indium. So that way we will say our answer out here is going to be D. Okay, all right, for question number 24. All right, okay, we will do it in the next video. Okay, I hope this answers the questions we have faced before, and thanks for listening. So keep visiting Sarasa classes for other solutions, okay, of the same paper, and thanks for listening. Have a great day.